Okay. Okay.
Teacher Jong, you can start the recording on the local device. Okay, ma.
Okay, already.
Okay. And first thing, maybe welcome, Professor Reggie. Hello, nice to meet
Thank
you.
you.
And
Thank you.
sorry, we forgot to calculate the daylight saving system. So maybe you can tell us about the system, because most of our students don't know this ideology. Why? So I just start with this. And okay, so today's talk, firstly, I want to invite Professor Reggie, who is a professor in the University of Stavanger, Norway. And how we want to distribute this is Teacher Jong will give the introduction to Professor Reggie and the talk in Chinese language, so our friends and our students can understand better, our teachers can understand easier. In the end, I will make a short summary in and thank you note in English. This way we have some bilingual nature in
Okay.
our
Okay.
system. Okay, ma.
Okay.
Okay, so I think Teacher Jong can say some words, and then we can begin our discussion.
Okay.
Hello, good morning, Professor
Good
Reggie.
morning. Good morning, Professor Whitening.
Yeah. Actually, our Western Professor here want to say hello to you, but unfortunately, he has another meeting now at the same time.
Okay.
So I told him that we can meet when you came to Shanghai next year. So no problem.
That will be my honor.
Okay, thank you. 那么我下面用中文跟各位同学和老师们解释一下啊。的确是因为我们的工作的有点疏忽哈，所以导致大家也等了这么一会儿。的确是关于夏时制的问题呢，在挪威这边。因为他们是属于东一区，我们是属于东八区，这个大家学过地理的人都知道这个概念哈。所以正常情况下，我们其实是差7个小时，但是我们因为安排会议是在10月份安排的，那么10月份这个时间正是他们的夏时制实施时间，他们从3月份最后一个星期天到10月份最后一个星期天都属于夏时制，他们会往前调1个小时，这样跟我们的时差就不是7个小时变成6个小时。那么所以我们在计算时间的时候都是按6个小时来算的，恰恰忘记了从今天开始，其实他们是开成了正常的时间啊，改成正常时间，所以说差7个小时。那么所以出现了今天这么一个问题。但其实夏时制这个东西呢，确实是有很大的好处的啊，至少说从白天我们时间调前了，然后能源节约方面确实有很大好处。而且大家对同学们来讲，可能大家觉得陌生，其实在中国我们也曾经实施过夏时制，只是我们实施时间真的很短。我们只实施6年，具体是在1986年到1992年。当然，对大家来讲，你们那时候大部分人都还没有出生。其实我是经历过的啊，因为我足够老，所以我经历过我们的那个时候的夏时制。我们从5月1号到9月30号，确实是我们是经历过6年的，做过夏时制尝试。但因为中国的地大，地面太大，然后呢，所以说如果是说我们按照一个标准来实施夏时制，可能对有些地方来说并不合适。所以6年之后呢，我们就把这个制度给取消掉了，所以现在就没有了啊，没有了。所以这么一个问题呢，被我们遗忘了、忽略了。所以这是我们学习到的一个很好的一课，希望大家以后在处理类似问题的时候有这样的一个经验啊。那么关于这个Reggie 教授呢，我要说的是这样的啊，他目前是我们这个挪威的斯坦万格大学的信息学的教授，同时他也是波兰西里西亚大学的一个访问教授。那么这位教授他的研究的方向主要是在信息方面啊，信息科技方面。那么如果大家这个要说学霸的话，我觉得其实在我了解了Reggie 教授的事情之后，我发现真正的学霸就是我们这位Reggie 教授啊，他的这个整个学习生涯当中获得了3个博士学位，大家不知道有没有关注过啊？我看他的事迹，我也是被惊呆了。2001年的时候，他获得了挪威科技大学工业工程的一个博士学位，然后2016年的时候呢，获得了克拉科夫科技大学在波兰这个大学的信息科学的博士学位，然后2022年又获得了波兰西里西亚技术大学的机械工程的博士学位，所以3个博士学位榜上，我相信我们的这个瑞教授已经是非常博学多才的。那么在 今天的这样一个交谈当中，希望大家能够有所收获。他主要研究了一些离散事件系统模型啊、仿真啊以及性能分析等方面的问题。我觉得对我来说太高深了，至少是说啊，希望同学们能有所收获。而且还有一个更好的消息，就是明年5月份的时候呢，我们的Reggie教授会访问复旦大学。所以正因为这样一个事情，让我们觉得，哎，我们会有更多的机会跟Reggie教授去交流。所以明年如果我们的同事们有兴趣去做这方面的研究的话，那么我相信我们到时候会给大家提供这样的一个跟Reggie教授共同研究的这么一个机会。如果我们同学们对教授的这个研究课题感兴趣，想要比方说将来到斯里兰卡大学去交流啊、学习啊等等的，我们也希望能够在跟教授的后期的接触当中，给大家创造这样的平台和机会。好吧，那么我要给大家介绍的主要就这里，下面我们就把时间交给Reggie教授，好吧？有问题我们会后的时候给大家留下时间来进行讨论。好的 ，Hello， Professor Reggie，
Yes, yes,
it's
yes.
now your time.
Yeah, thank you, thank you. I wish I understand some Chinese. It's a beautiful language and one of the most important languages of the world. But I will promise you this, Professor Weibing and Dr.Hurry-ish, when next time I will visit Shanghai in May next year, I will be speaking at least a little bit of Chinese. I promise you that.
Thank you, thank you. Welcome.
Yes, yes. So I can start now?
Yeah, no problem.
Yes,
Yeah,
yes.
welcome.
Let me share my screen.
Okay.
And here we are, I think this one.
Yeah, so there's a button that says, yeah,
Yes.
okay.
You can see my screen now?
Yes, yes.
Yes. And it's changing now, is it?
No, the slide. Yes, yes. Okay, okay, okay. Very good.
Yeah. Okay. So today I'm going to talk about discrete systems and how it can be used in management science, business and management science. Traditionally used in engineering, but I'm going to prove that it can be used in business and management environment also. And it's a very useful tool, and many people are using it. So let's see what it is. Of course, as Professor Weibing introduced me, I am Reggie and I'm working at the University of Stavanger, Norway right now. But I will tell you I have some other jobs also. So let me say a few words about me. And this is an academic lecture. So we always talk about our academic degrees to introduce ourselves. So I have a bachelor degree in physics and a master degree in control systems engineering. And then my first PhD, first doctoral degree, was in industrial engineering from the Norwegian University of Science and Technology in the year 2000. That was industrial engineering. Then I started working with the computer science group. Then I needed one more doctoral degree to teach my computer science students confidently, So you need to have one more degree so that you can teach with confidence, okay, with a big smile on your face. So I got one more doctoral degree in information sciences. That was in 2016. Then I started teaching also these Polish students in Poland, but they are mechanical engineering students. So how can a guy with industrial engineering and computer science background teach mechanical engineering? That was a big question for me. So I did one more PhD in mechanical engineering. I got it this May. This May, I went to Poland to receive my doctoral degree. Okay. So as you see, all these degrees are in natural sciences and engineering, not in business systems. Wrong. I have very good experience with business systems, okay? Because I was the editor, one of the 3 editors of the International Journal of Business and Systems Research. And I was one of the 3 editors until last year. Last year I resigned because too much work. Also, I was one of the founding associate editors of the journal Electronic Government. Me and my good friend Binshan Lin, he is in USA, we started this journal together in 2006. And then after 8 years, I retired. 8-9 years, I retired. I am also the editorial board member of this industrial management and data systems. Resigned 5-6 years ago, 7 years ago. And then I'm still working for the Business and Management Quarterly Review. This is a small journal by a Malaysian university. It's a local journal. I'm still associate editor-in-chief for this journal. And I still work for this International Journal of Scientific Research in Education. Okay, I still work for them. So I have good background in business and management. I can assure you that. Okay, so this is my background. So where do I work? Here is my main work is Professor of Informatics at the Department of Electrical Engineering and Computer Science at the University of Stavanger, Norway. Here is my main campus. As you can see, it's a beautiful place, just like China. Very nice, beautiful places are here in Norway too, not only in China. Okay, yes, Norway is one of the beautiful countries, yes. So if you don't know where this Norway is, it can happen. So here it is Norway. Here we have Sweden, and then we have Denmark. Norway, Sweden, and Denmark are called the Scandinavian countries. The rich and famous Scandinavian countries, Norway, Sweden, and Denmark. In addition, we have Finland, and Iceland is somewhere here. Sorry. So all these 5 countries are called the Nordic countries. In addition to Scandinavia, we have Finland and Iceland. Together we call the Nordic countries. So this is my main work, where I'm a professor of informatics here, working with the computer science group. I also have a visiting position. I spend 8 weeks a year. I travel 8 times to Poland to teach mechanical engineering students there. So here is my university in Poland. It is called the Silesian University of Technology in Gliwice, Poland. If you're not sure where Poland is, here is Poland. As you can see, my university is in the southern tip of Poland. Very close to my university is the Czech Republic. And then we have the Slovakia and Berlin, and Germany is here. It's about, so sorry, it's cold here. Norway is well known for coldness during the winter time. So Berlin is about 9 hours by car, okay, if I follow the speed limits. And then we have the Ukraine here. Ukraine is here. And then we have the Belarusia, and then the Lithuania, and then the Russia. Okay, all these countries are close, surrounding neighboring countries of Poland. So what do I teach in these 2 universities is mathematical modeling. Mathematical modeling of computer systems in Norway, mathematical modeling of mechanical production systems in Poland. Now I am teaching you mathematical modeling of business and management systems. The mathematics is the same. The application is different. Okay? Yes. All right. So today is the agenda. This is the agenda for today. First, I'm going to talk about why discrete simulation, why it is necessary. Then I'm going to talk about I can say it's the mathematics. It's not mathematics, it's called the mathematical formalism. It's not mathematics is algebra is mathematics, trigonometry is mathematics, okay? And then you have, so this is not mathematics. This is basically a formalism, a set of ways to do. Okay, so that is Petri nets. We will see what it is. And then I'm going to show you an application in management science. Why we need to study Petri nets. So, and how beautifully we can solve problems in management science, business and management. Okay. And then I will introduce my tool GPenSIM. GPenSIM is a tool I developed, which is giving me a lot of, how can I say, visibility. Okay. That is why I'm coming to Fudan University next year, also to your university, University of Shanghai, to teach about my tool and how we can use it to model business systems. In Fudan University, I'm going to teach computer science students and how to use my tool. Okay, the GPenSIM, and then I will conclude with some positive remarks. Since you guys are good students listening to me rather than playing with your iPhone, your mobile phone, sorry, I will also say something about studying in Norway. That is the bonus, okay, for being nice students. Okay, so this is the agenda. Let me see. Yes, we are on time. So why we need discrete simulation? Why is that? So discrete systems, as given in the poster, change with they change state at discrete point of time. Okay, it's not like a chemical reaction which gradually change in discrete times. For example, if I apply for a loan to a bank, until the manager says accepted, this application is pending. Okay, the application is pending until the manager presses the button accepted. Okay, so when the manager presses the button accepted, the status of the application, my bank loan, changes from pending to granted in one discrete time. So this is what we call discrete systems. Things happen at discrete time. It doesn't take time to change. Okay, we are not concerned about the rate of change. Things happen whenever there's a button press, things happen. Okay. So business and management systems are complex and large, that we know. Okay, it's these days business systems are super huge, and most of them are discrete systems. You don't see somebody changing the status with slowly, you know. They work on a case and then they decide, yes, accept or reject. Okay, and so basically management systems are also discrete systems. So if the management systems are large and complex, how can we optimize the system? For example, how can we reduce the time taken by the system? Again, going back to the bank loan, if I apply for loan, we have to reduce the waiting time, because if the application takes too much time, it is not doing good for anybody. Okay, so we have to reduce the time. So that is we call the cycle time. Bottlenecks. Why it is taking too much time? Somebody is delaying. Somebody is some resources. It could be some bank official. It could be some other thing, a software system, whatever. Or maybe getting the document in time, the postal system, or maybe the clearance of some documents. Something is blocking the system. So we have to find out what is the bottleneck. Okay, so we can improve we can make the system process faster. Sometimes the application is not going anywhere because it is waiting for 2 or 3 people, but one or more of them is always occupied. Sorry. Okay, the application is deadlocked because it must be processed by a couple of people, bank official, and either one of them or more of them are always busy with something else. So then we have a deadlock scenario. Okay. And how many applications can this department process per week, per month, per year? Okay. That is the throughput. All this thing can be found out. And finally, what is the total cost of processing? Because nobody works for free in a bank. Everybody is paid handsomely, okay? And the office space takes time, the electricity takes cost. The office space takes cost, electricity costs money, and insurance costs money, everything costs money. So we want to know how much money the bank is spending on processing one application so that we can think about how much profit we can make, okay? So all these things can be found out if we have a mathematical model. When we have a mathematical model, we can simulate it and find out the cycle time, which is the bottleneck, if the system has some deadlocks, how many applications can be processed in a month, in a week, okay? What is the total cost? All these things can be found if we have a mathematical model, okay? Good. So for mathematical model, we are going to use Petri nets. Petri net was invented by a German researcher in his PhD in 1962. And it was very well known for many years. And then after that, from 1990, it began to lose its popularity because the models become very big, huge. It's difficult to process a huge model. Then I released my tool GPenSIM, with which you can somehow solve the problem attached to its huge size. That's why my tool is popular. So now you can, again, use Petri nets. So, but what is Petri nets? Okay, let's take a simple example. Okay, so Petri net, in Petri nets, if you take a discrete system, it has active elements and passive elements. It's a very simple idea, okay? Hang on with me, okay? Don't lose your interest. It's a very simple idea. So Petri net is a discrete, if you use Petri nets, a discrete system. Take a bank loan system, okay? Loan processing system. Process, okay? It has two types of elements. One is active, like humans, you and me are active, and passive elements are the ones that are not active, okay? Passive is the chair you sit is passive. It doesn't do anything, just keep you there. The desk you use is passive. The screen we use is passive because it just shows something, okay? So we have active elements and passive elements. Excuse me. Okay. In a Petri net, the active elements are called transitions, okay? Here we have transitions, which are active elements. They do something. They create something. They change something, okay? That are the active elements called transitions. And then we have the passive elements called places, okay? Places are not, here we have places, the circular things. Places are passive, like a hard disk of a computer. It just keeps software and programs and files, okay? Like your chair, like a buffer, okay? In a manufacturing facility, buffers, input conveyor belts, okay? Output buffers, and then you have the baskets, which just keep things, the waste paper basket, okay? These are passive things. So then we have the arcs. Arcs connect passive thing to active things and active things to passive things. Okay? We cannot connect a passive to passive, active to active. We cannot do. Only passive to active and active to passive. Okay? So that's why it is called the bipartite graph. Finally, we have tokens. If you take a financial system, there is something that flows through the financial system, which is the money. It could be cash, or it could be electronic money, whatever it is, but it is the money, flows through the financial system. If you take this computer system, what flows through the computer system, computer network, which is the data packets. Data as packets flows through the computer network. If you take a manufacturing system, it will be semi-products first, and then it becomes products, and finally, first it is raw materials, which becomes semi-products, and then finally it becomes products. Again, if you take a large manufacturing system, in comes these raw material, machines work on it, make semi-products, and then further machines work on the semi-products, making the final products. So financial system, something flows, which is the money. If it is a computer system, computer networking system, it is the data packets. If it is a manufacturing system, it is the materials. Okay. So anything that flows through the system, we call the tokens. Okay. So this is what a Petri net is. Okay. With this idea, we are going to develop the first mathematical model. Okay. Be happy about it. We are going to create the first mathematical model. Okay. For that, we take a simple example. Okay. Let's take a very simple example. Okay. So here we have two input conveyor belts. Okay. First input conveyor belt brings in green items. The second input conveyor belt brings in red items. It's a very simple manufacturing example. Very simple. Okay. So we have two conveyor belts bringing in two types of material, the green input material and the red input material. Okay. Then we have a robot which take one green item and two red items and solder together. Sorry. You know what is soldering? This fusing it together, okay, joining it together. And then the robot will put this semi-product, okay, from raw materials. We have now created semi-product. The robot will put the semi-product into the input buffer of a cutter. Okay. So the cutter will take the semi-product and cut into 3 pieces. Okay, that is the simple example. Okay, you can't find any simple example in manufacturing. Okay, let me tell you again what I talked about. So this manufacturing facility has two conveyor belts. The first conveyor belt brings in a green item, input material. The second conveyor belt brings in the red input material. Okay, raw materials. And the robot take the green raw material and one of them and two of the red raw material and fuse them together. Then the robot will put this semi-product into the cutter. The cutter will take the semi-product and cut into 3 pieces. And this is the final product. Okay. So now we are going to build a mathematical model. You might ask, why we need a mathematical model? Professor, are you wasting our time? No, not at all. Okay, you guys are busy guys. Thank you for attending my lecture. Okay, we are not wasting our time here. Okay, I can tell you for 2 reasons we need a mathematical model. Okay, first thing is that when the green items comes here, okay, and the red raw materials comes here, they are not free. We bought it from a supplier. Okay, they have some costs. Okay, so they are not free. They cost some money. Okay, so when the robot works on it, okay, robot is not working for free. We have invested money on the robot. So that means we are spending money when the robot is active. Okay. Robot is also has 2 types of cost. One is fixed cost. even if it is not working, we have to depreciate the investment every time. Okay, that is the fixed cost. Then the variable cost. When the robot is working, it has to use electricity. After a couple of times, we have to stop it and maintain it. So that's the variable cost. So every equipment has two types of cost, fixed cost and variable cost. I'm sure you know about it, okay? Then the cutter. When the cutter takes the semi-product, when cutter works on it, it also incurs two types of costs, fixed cost and variable cost, okay? So if we add all these costs, the original cost of the input material, the cost of this robot, both fixed cost and variable cost, also the cost of the cutter, fixed cost and variable cost. Finally, we can find how much a product costs. Okay? If we were to make this product in our factory, how much it will cost. Then on top of the cost, we can add our profit margin. Then we know what price we should sell. Okay? Simply having a mathematical model, we can find the cost of this product if I were to make it in our factory. If the cost is too high than what we can buy in industry, outside market, why should we make it? We are not going to make money, okay? So the cost should be lower than the market price. Then we can add a profit and sell, okay? So one is to find the cost. Second, if I put all this time, the time of the conveyor belt, how fast it is, the robot, how fast it can work, the cutter, how fast it can work, I can find the throughput. How many products can I make per day? Okay. If it is, I am not happy with the throughput, then I had to replace the robot with the faster robot, the cutter with the faster cutter. How much time I'm going to spend on these things? Then I had to think about the performance over cost. If I change the robot, I can make more products at what cost? Okay. So all this can be found out with a mathematical model. Okay. So let's going to make a mathematical model. Okay. All right. Okay. First, in this discrete system, first this is discrete because nothing happens with time, Robot takes, puts, it's joined together, and cutter takes, pang, 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 it cuts into pieces. So everything happens discrete time. Sorry. So let's going to make a mathematical model of this discrete system. First, we have to find the active elements. So there what that we know. We have two active elements. One is the robot, the other one is the cutter, which actually do some useful things. Okay. What are the passive elements? Passive elements, we have four elements. The two conveyor belts are passive. They just bring things. And the cutter has one input buffer and one output buffer. Okay. Into the input buffer, the robot puts the semi-product, and the robot cuts the semi-product and put the output products into its output buffer. Okay. So we have two active elements. Okay. Two active elements and four passive elements. Then what are the connections? Okay. We know that robot takes one green at a time and two red at a time. Okay. Then it makes one semi-product. Then I don't have to show. If it is one, I don't have to show. Then the cutter takes one semi-product and chop into three pieces. Okay. If it is only one, then I don't need to show. Default is one. Okay, sorry. Now, what are the things that flow through the system, the tokens that we know? Here we have the green item, green input material, red input material, which becomes the semi-product. Finally, it will become the products. This is the things that flow. Now we have found everything. Okay. Be ready. I'm going to show you the mathematical model. Okay. Voila. Okay. This is the mathematical model because here are the two active elements called transition, the robot and the cutter. Okay. And we have 4 passive elements, conveyor belt 1 here, conveyor belt 2 here, and the input buffer of the cutter and the output buffer of the cutter. Sorry. And then we have the connections, arcs, and the robot takes 1 green item, robot takes 2 red item, it makes 1 semi-product, cutter takes 1 semi-product, and chop into 3 products. This is the complete mathematical model. Okay. In this model, if I put timing, how much robot takes to fuse, solder, how much cutter takes to chop into 3 pieces, I can find how many products we can make in a day or in an hour. Okay. Also, if I put cost to the input material, how much each green input material, raw material costs, how much each red raw material cost, what is the fixed cost of robotic operation, what is the variable cost of robotic operation, and what is the fixed cost of cutter, what is the variable cost of cutter, then I can find the cost of the products. Okay, so all these things can be found. This is a very simple example. If it is a large example, as we will see in a minute, business system, then we can find what is the cycle that is delaying the system, what is the, so many things can be found. Okay. So congratulations, we have made our first mathematical model. Okay. But as we see, this is for humans. We can see what it is. We know this is a robot, this is a cutter, which the 2 active elements, and we have 4 passive elements. The conveyor belt 1 and 2, input buffer, output buffer. Computer cannot simulate it. It needs mathematical equations. So that is where my tool comes, GPenSIM. It transforms this graphical information into linear algebraic equation, okay? So that computer can iteratively work on these equations, okay? But we skip this mathematical part for now, the linear algebraic equations. For that, when I come next year, if you are interested, I can give you 2-3 days seminar to teach those mathematics also. Very simple mathematics, okay? But within 1 hour, we can't do it, unfortunately, okay? All right. Now I am going to give you an application in management science, okay? That will be interesting, your area, okay? All right. Sorry, I take this example from a paper by this Daimura et al. It's published in 2019, okay? So take this example. The example is about cash loans, okay? We know that banks made huge amount of money by giving loans to individuals, but mainly to businesses, okay? Individuals, they give loan, of course, but they make money, of course. Bank very rarely lose money, but they make huge money by investing in companies, okay? By lending money to companies. So it's a very complex system, as you know, for sure. But we will think about it, okay? So this is about let's say that somebody wants to, somebody is a little bit careless about their credit card use, okay? And you can see that the financial data is not good. Too much money on his credit card, okay? And too much debt. And his personal data is also not that convincing. He or she has a big family and a lot of debts everywhere, okay? And there are 2 things can happen. This person, since he has too much money, debt in a credit card or a couple of credit cards, he want to apply for a loan to bank to settle these credit card loans, okay? So that is the passive way. The bank doesn't do anything unless a customer apply for loan, It could be an individual customer, it could be a company. A company has liquidity problems, so they apply for a loan. Or they want to expand their business, they apply for a loan. Okay. And then the bank, okay, the consultant, the bank official will, if there is a loan application already, they will process it. They will look into the financial data. Then they will identify from their credit card usage, how the customer is doing, okay? Also, they will look into the personal data, his family history and his other loans, his house and everything, okay? Mortgages and everything. And then they will think about an offer, okay? And then they will sign it and pay the guy, okay? If it is a individual customer, personal customer, I mean individual customer, then it is easy. If it is a company as a customer, then it will be much more detailed. So it could be a consultant. If it is a company, then we need some analyst also. Okay, not just a bank official. We need to dig into further. We had to think about the company and make some SWOT analysis. I'm sure you know all these things. So the strength of the company, the weaknesses, these opportunities, the threats, the company's current liquidity and the leadership, their involvement in what kind of business. Is it a sensitive business? Is it a commodity business? So everything has to be looked into. So we need analysts at the banks. And finally, if the analysis and the consultants are completed their processing, it's up to the manager to approve or disapprove. Okay. As you can see, if it is an individual customer applying for bank loan, there is still a lot of steps. We have 11 steps. Okay. But if it is a company that is applying for money, it will be very much detailed, depending on the size of the company and the type of business. Okay. If it is a risky business or something like that. Okay. All right. So let's say we are the bank and we want to, bank and loans are the best way to make money as we, the bank. So how do we optimize all these steps so that we can make most money? Okay. How do we do it? Okay. Because there are a lot of consultants working for us in our bank, analysts, managers, and nobody's working for free. And these people are expensive. We are paying nice salaries. Okay. Also, in addition, there are resources, bank office, software, and communication, and everything costs money. Okay. So we need to make profit. Otherwise, bank will vanish, okay, from business. Okay. But look to these 11 steps. Okay. Okay. There are many ways we can arrange these steps. It's not in a linear order. There are many ways we can do it. Hundreds of ways we can do it. Let's take, for simplicity, let's take 3 simple approach. Okay. L1 is the passive defensive. Okay. The bank doesn't do anything unless somebody apply for a loan. That is passive defensive, because bank is more concerned about not losing money on bad investments. Okay. So we just wait until somebody apply for a loan. So once we receive the application, then we will look into the, let's say, individual customer. Okay. And then we will look into his credit card usage, how good or how bad he uses his credit card, and other type of what he buys. Okay. All these things we will focus. And then we will look into his personal data, his family background, whether he has a house and everything. And then we will look into his financial data, and there are a lot of things we will look into. Okay. And after all these things, we will think about an offer. Okay, we will give you a loan, which is 500,000 yuan at the interest rate of 20%. We can't give you anything better. Okay, something like, because you are a risky guy, something like that. Okay, so this is the passive defensive. Okay, the other one is active defensive. Okay, when a customer is using his credit card, we can get data from this credit card company. In Norway, they do it. Okay, if I use my credit card too often, automatically my bank gets information from the credit card company, and I get an offer. Reggie, you are using your money lavishly. Would you like a loan from us? Okay, I don't have to do anything. The bank sent me an email. Reggie, would you like a bank loan? Okay, so that is active defensive. Okay, so we, the bank, don't sit to sleep. Even before a customer apply for money loan, we will be checking into their credit card use, their personal data and everything, and we will be ready. At one point, whether he applies or not, we will come up with an offer. Hello, Reggie. I know that you have not applied for a bank loan, but we are willing to give you a bank loan. Okay, so that is the active defensive. The third one is active offensive. This is what small companies, they are not banks, they are finance companies does in Norway. Okay, they are active offensive. Okay, so once they understand a customer's financial situation from a bank, they immediately offer a bank loan. They offer a loan. Sorry. Okay, so this is active offensive. Okay, so they get data from the bank about a customer's money usage, and then immediately they send an offer. Here is, we can give you a loan. Doesn't matter you need it or not, you can take it from us. Okay, the interest rates are high. Okay, but people who use credit card lavishly love it. Okay, so this we call active offensive. Okay, so as we see, as a credit card, as a bank, we have people working for us, and there are a lot of steps involved, and there are some policies. We can be passive defensive, active offensive, whatever it is. The idea behind everything is to make a large profit. Okay, so how can we check all these possibilities and come up with the best option for us, the bank? How can we do it unless we have a mathematical model? Okay, we need a mathematical model where we can apply all these policies and pick up the best option for us, the bank, so that we can make the most money. Okay, all right. So here I show you a simple Petri Net model. This is not, the real model is very, very big. I can show it in one page. So here, for example, let's start here, the customer apply for loan A, okay, which is customer apply for loan. And here we check the personal data, bank check the personal data. Here the bank check the financial data, the customer's credit card usage. And here the credit, so there are several steps, okay. So you can do it one before, one after. There are so many ways you can do it. Also, each step has to be run by a consultant or an analyst, okay, a human, a bank official, and it costs money, okay. And some of these steps has to be done by 2-3 people, okay, not one but 2-3 people. Some of these steps are automated. You don't need people to do it. The software can do it, okay. So every step has cost. Every step has people behind it. And all these steps can be done in so many different ways, okay. So if we have a mathematical model, we can try out all these possibilities, whether it is active defensive, passive defensive, active offensive, whatever it is, okay. And find how much it will cost for the bank and how much time it will cost, okay. If it is slow, who is the culprit? Who is delaying things? Okay, we can find it in a mathematical model. Okay, so with all these things, we can answer if we have a mathematical model. Okay, very good. So you can ask questions if you want, but maybe after the lecture, it's up to you. Okay, so the last topic before the conclusion is GPenSIM, my tool. Okay, so when we have the mathematics, which will give you a large model, it's not easy to do it by hand, of course, because the model will be super large. Okay, so I developed GPenSIM to teach my students. Okay, to teach my computer science students initially. Okay, so in 2008, I developed GPenSIM, the first version, to teach my students at the University of Stavanger, Norway. Okay, and every year I improve my tool. Version 10, I completed in 2018, is used by 22 universities, including Fudan University in Shanghai. That's why they invite me next year. 22 universities, at least, as far as I know, 22 universities in 14 countries, from Australia to USA. Okay, they use it. Okay. And 8 PhDs were done using my tool as this strategic software. Based on my GPenSIM, there were 8 PhDs, 3 from Norway, all of them are my students. 1 from Michigan State University, 1 from Malaysia, 1 from Brazil. I know I still have contacts with that guy. 1 student from Poland, 1 from Saudi Arabia. These are the people I know. I don't know how many others are there. And there are many master theses done with GPenSIM. Okay. And for you guys, GPenSIM is also very good for modeling business management systems because they handle resources efficiently. I'm not going to prove it, but I will show you my books later. If you want, you can download these books. I think you from the library you can get it, and you can study it. Or wait till next year if Professor Weibeng will arrange a seminar and Dr. Hurry-ish will arrange a seminar. I will be happy to teach. How do we use my tool to model any discrete business systems, business management systems? Okay. All right. So why GPenSIM is popular? Okay, I don't want to talk much about loud about my tool because I'm a humble guy. Okay, in my culture I cannot talk loud about my own creation. Okay, so I let these Australians say why my tool is best. So here we have a couple of Australians. The first 3 people are professors in the University of South Australia in Adelaide. The final 2 people are from the Defence Academy of Australian Defence Academy. They were looking for a mathematical tool that can help them model their military communication system, whatever it is. Okay, so they were looking for a tool. And here, this is what they say in their paper. Okay, they published this paper in 2015. Here they say there are a lot of tools. Of course, the world is big. There are so many tools, wonderful tools, of course. So what is ideal? What is best? Sorry. The GPenSIM is ideal. GPenSIM is the best. Why is that? Because it is flexible. It can model business, it can model computing systems, it can model mechanical production systems, it can also model business systems. Okay, so that's why it is popular. So that is the Australians. Let's move to America. Here we have the Michigan University. University of Michigan is one of the, excuse me, sorry, I have a sore throat. Thank you. University of Michigan is one of the top universities for production engineering, mechanical engineering, and robotic engineering. Okay, one of the top. So here they thank me for creating GPenSIM, And in their paper, they say they want to model a large manufacturing facility, large factory. And then they were looking for a tool. They shortlisted 4 tools. Petri Net Toolbox, SIM HPN, Hyphens, and GPenSIM. They were the shortlisted. And finally, they choose GPenSIM. Again, why is that? They say it is flexible. You can model anything you want, okay, as long as it's a discrete system. All right. Let me see. Conclusion, okay. The mathematics, it is basically modeling approach that is Petri nets, and GPenSIM are simple to use. You can study quickly, very easy to study, and very easy to use. Okay. It can solve large-scale problems. For example, business management systems of a bank, okay, cash loan processes, lending money processes. It becomes pretty large, and we can model it and solve it. Okay. You can add money. Some of the mathematical models does not accept money, which is crazy. Only time. This world is basically about money. Okay. Sorry if I'm wrong. So cost must be there, and my tool accepts supports cost calculations. Okay. Traditionally, discrete system modeling is done in engineering, but these days it is also done in business process management optimization. If you have a business process, how do you optimize it? Okay. Finally, if you want to download the software, here is this web page, GPenSIM web page. You can go there and download. Okay. So this is the web page for GPenSIM. This is the first book I published in 2018. This is a simple user manual. If you want to learn GPenSIM, just get this book and go through. It's just about 140 pages. It's a very simple book. Anybody can learn it. If you want to learn the advanced techniques, okay, then this is the book I published in last year, but it says 2022, the official publication date, but I published in last October. So this is the advanced topics. For those who are inclined, mathematically inclined, can read this book, okay? But if you don't want to get into complex mathematics, not complex, detailed mathematics, then the first book you will do. Okay. All right. So since you were nice guys, you were not looking into your phones, watching my lecture, I'm going to talk about studying in Norway. Okay. Just takes 2-3 minutes. Okay. This is beautiful, isn't it? Yeah. Norway in winter.